In this chapter, we're going to study trigonometry. This lesson is about classifying triangles.
Okay, hi everybody. So in this lesson here we're going to look at just classifying triangles. And once again, we're just trying to remind you of some stuff that you would have seen a long time ago, but we just need you to remember how this works here. So triangles can be classified in two different ways, really, by their angles, okay? Whoops. Or by their sides. Okay? Now, if we take a look at classifying triangles by their angles, then we've got three options here. You could have a right triangle, in which case you've got a 90-degree angle somewhere in the triangle. It's usually marked off by that little square. And you're familiar with that. You would have seen that. Because anytime you talk about the Pythagorean Theorem, you have to find that angle in that triangle first. You could have an acute triangle, okay, where each one of these angles is less than 90 degrees, right? So all angles, okay, are less than 90 degrees. Or you could have an obtuse triangle, in which case you're going to have the one angle, and it can only be the one angle, but one angle is larger than 90. Okay? And so those are your three triangles: right, acute, and obtuse. But that's just the first way of classifying triangles. The other way that we might classify triangles is going to be according to their sides. Okay? Now, a triangle where all three sides are equal, and that's what this little mark here means. As soon as you see that, if you see the one there, I know that those are the same size. Okay? Here, in an equilateral triangle, equilateral means they're all the same side here. The isosceles triangle has two sides that are the same. The third side isn't. The third side will be different, because if the third side was the same, then it would just be an equilateral. So just two sides are the same here. Or you could have a scalene, okay? A scalene triangle, in which case all of the sides are a different unique length. Okay. Now, one thing that we might notice here, and this is actually kind of an important little point here, and I've just got it right here, and I'm going to highlight that if I can here. Okay. And that is that in every triangle, the side opposite the largest angle is the largest side, and the side opposite the smallest angle is the smallest side. Okay, that is always, always, always got to be the case. Now, you can probably get a good view of that when you look at this right here. So here's your obtuse triangle. It's got this obtuse angle in it. Okay, and there can only be one obtuse angle in the triangle. There can only be one angle that's larger than 90. And notice that because it opens up so wide, the two basically the arms of this angle, their endpoints are far apart from each other. So it opens up to the largest side here. Okay. Whereas this angle right here is quite a bit smaller. It opens up to a much smaller side. So that's a little rule that if you kind of remember that, if you kind of keep that in mind, it helps you kind of verify if you've done a question right or wrong. Okay, so this question here, we're going to classify the following triangle according to its sides and its angle. Well, I can see right now, because of that little mark there, that this has got a right angle in it, so I know that this is going to be a right triangle. Okay, I know that because of that. Now, I know that the hypotenuse is going to be the longest side in a right triangle, so I know that this side is going to be longer than both of those two. And then I can clearly see that this side here is longer than this side here. So because none of the sides are the same length, I know that this is also a scalene triangle. Okay, so it's right and scalene. Okay, classify triangle ABC according to its sides. Okay, well, I mean, the three options here are going to be equilateral, isosceles, or scalene. So now, take a look at this, and it's triangle ABC. So what's the big triangle that I'm looking for here? But it's been divided up into two right angle triangles. Now, take a look at this here. What I'm going to do here is I need to figure out the two bits of missing information. I need to figure out that side, and I need to figure out that side. So let's do X first here. So I know, because this is a right angle triangle, that I can use the Pythagorean Theorem. So I know that 4 squared plus 3 squared is going to equal x squared. And so that will be 16 plus 9 is equal to x squared. 25 is equal to x squared. And then when I take the square root of both sides, I'll get that x is equal to 5. So, well, now wait a second, that's kind of interesting here, because look at this, look at this. This is 5, Okay, 3, 4 here. But this side is also 5. So this could be an isosceles triangle. And I know that if this hypotenuse is the same as this one and this side is the same, well, gee, this has got to be 4. Now I'm just going to verify that. If I go y squared plus 3 squared equals 5 squared, y squared plus 9 is equal to 25. Now what I'm doing here is I'm working on this triangle now. So 5 squared and the 3 squared. If I bring that 9 over, I will get 16, and there it is. Y is equal to 4. So what I've got here is a triangle where this is going to be 5, this is going to be 5, and this whole side across the bottom, 4 and 4, this is going to be 8. Okay, so, well, that's got to be an isosceles triangle.